So, in particular, jump is the situation when in a loop we want to skip past the rest of the statement, jump forward, right, in the loop so that it goes back, or we want to get out of the loop. So to jump forward, to jump forward in the sense that we want to skip past certain statements in the loop sequential block, right? We want to skip past that, and at the end of the block, we always automatically go back to the beginning. Yeah. So for example here, if we didn't have the continue, what that does is I is even, I becomes odd, then Python will continue to this statement if I is greater or equal to 9, and that 8, sorry. So that would be not nice, because suppose our logic is if I is even, increment I by 1, then go back to the beginning again. How can we say that? How can we say that? So the way to say that is to say continue, right? So if I is even, then I equals to I plus 1, and continue means go to the end of the loop, because there's nothing else, the loop will go back to the beginning again, right? Continue on to the next loop. So continue is a special kind of jump. No matter where inside a loop, the moment you put in a continue, it will go back to the beginning of the loop again. You can think of it as go forward to the end of the statement block, then jump back. So in that sense, it's jumping. It's not like a loop where when it comes to the end of the sequence block, it automatically, that's a loop, it automatically always goes back to the beginning, right? So that's looping. But somewhere in between, you like to skip past all the rest and go to the end of the statement block, right? That's continue, the statement continue. Now, another need for jumping is to jump out of the loop. We call exiting from the loop. Exiting from the loop. The right keyword to use is break. So we need these two these two keywords to help us manage the loop properly. Okay, so in particular for break, for example, oftentimes when we run loop, especially with while loop, where we don't know in advance how many times you're looping, potentially infinite number of times, if inside a while loop you don't have a break somewhere, inside a while true loop, that means an infinite loop, you don't have a break somewhere in there, I can straight away tell that it's going to be very problematic, because you need to break out of an infinite loop, definitely. Otherwise, your program will always be doing the same thing. So again, unless you know what you're doing in a very niche kind of programming, you really have to have a break somewhere in the loop. All right, let's just try out the codes and see. Okay. So what we can do is we can initialize the loop using a while. Remember, continue and break, they can be used in any loop structure. So that means whether it is while or for, both are okay. All right. So actually what we want is while I is less than 20, right, then we do a check. If I is even, right, if I divided by 2, the remainder is 0, then I equals to I plus 1. And we, at this point, decide to continue. All right, so that means if it's even, make it go to the next integer and check again. Do nothing but check again, right? Otherwise, now you see that this is actually else. Otherwise, if I is greater or equal to 8, break. Otherwise, print I, all right, where the end is not a new line but a space. That's just to make sure our numbers go horizontal rather than go vertical. And then I plus equals to 1. So first of all, let's have a brief analysis. All right, so first set I to 0. We will keep doing so long as I is 0, 1, 2, 3 until 19, not 20, 19. 19 included. So when I is 0, 0 divided by 2, remainder is 0, right? So I becomes 1, and we continue. We don't even come here, 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 here. We just jump straight back. Is 1 less than equal less than 20? Yes. So 1 mod 2 1 mod 2, the remainder is 1. So we won't do this whole 2 lines here. We jump to line 13. Is 1 greater or equal to 8? No. So we don't break out of the loop. We don't jump out. We don't jump out. We continue, right? So that's 1. We're going to print 1. 1 becomes 2. All right, 1 becomes 2. So 2 here is going to be even. So 2 becomes 3 and do nothing. Just go back again. So in other words, we are skipping away all the time, all the even numbers. Whenever it's even, go to the next odd number and skip past all the remaining lines and go back to the beginning, right? So we have 3. Is 3 greater or equal to 8? Not yet. Not yet. So we don't break out of the loop. We don't exit the while loop. We continue. Yeah. So we'll print 3. Then we'll print 5 because it's not yet greater than 8. Then we'll print 7 because it's not yet greater or equal to 8. Then we are going to print 9 because 9 is here. But before that, is 9 greater or equal to 8? Yes. Then we exit. So we will not see 9 being printed because these two will not be executed at all, simply because the break was here to so-called break out of the loop. Okay, let's run it. Okay. In case it's a bit cluttered up. All right, so we see 1357. 1357. Suppose, imagine we don't have this, just canceling them out using a comment, which means Python will be ignoring them. Even though we can see them, it's not being executed. So we will skip past all the even numbers and print out only the odd numbers below, strictly below 20. Can you see that? Okay. Yeah, so we will do that. So without this continue, then without this whole check, right? So what happens? Basically the loop is just this, just what we saw just now. So print 0, 1, 2, 3 until 19, including the even numbers, odd and even numbers, right? So if we reinstate this, all right, if I is even, then I equals to I plus 1. Yeah. Suppose we don't have continue. All right, so this is deleted, no continue. Then what happens? So if I is even, I becomes odd, but it will be printed one time and then added with another number. So I becomes, instead of 3, becomes 4. So it will be all rather slightly different, right? Because here, look, at first I is 0, we increment to 1. Okay, then we print 1. Then 1 becomes 2. But the next time round, I will be 2, which is even, and then we add 1, print the odd value 3, then make it even again, right? Yeah, so this is rather not the right thing to do because we are incrementing 1 by 1 very slowly. We could have just incremented 2 directly. Yeah. So at this point, if we also include the break, okay, what will happen? It will truncate at 8. That means 8 included. Anytime it's greater than 8, it will break. Right. So the continue here seems to be not useful, right? Because it is somehow also carried out by the logic. But if we have this, then it will make quite a lot of difference because I now is 1 because we know it is even, but even you get 1 added to the even 0, it becomes 1, right? So then we print out the 1, and until I is greater or equal to 8, then we exit from the loop. But suppose we insert a continue here, what will happen? What will happen? Well, this is going to be ignored. Okay, so we are back to square one, as if all these sequential statements, they are totally not present. They are totally ignored because continue basically instructs Python to skip past all the rest of the statements, go to the end, but for a loop, that just means go back to the beginning. You see that? So continue and break, they are very powerful uh, control keywords, especially within a loop, to jump ahead, continue to the next loop, or break out and then continue from where the loop started, the next line after the loop started. So these are the keywords that allow us to jump. Yeah, so that's jumping. And if we have, for example, here, another example. Okay, so where here we are using the aggregate version, right? But this time with a bit of a twist. So just now we were aggregating over the daily profits with a total variable. So for I in this list of daily profits, all right, if I equals to 0, then we break out. That means whenever there is a 0 profit, okay, let's stop and see what happens, right? Let's stop the summation process, the totaling process. If I is less than 5, then we say, well, suppose any revenue that's less than 5, that means 43210, other than 0, we come out, but 4321, too little, let's skip it. We only total up the big revenue, right? Then the continue will do that, because whenever this condition is true, the statement will be executed. So whenever there's small revenue, continue will run, which will continue into the next for loop. All right. So for example, when we encounter 1, it will be true here, and Python will execute continue, jumping to the next value of I, which is 0, which will bring out the loop. Okay, so up to here, then we are done. So what happens is we will, first of all, initialize I to 1. Right, so see, this is not 0, we won't exit. This is small, so we skip it. So then we add, then I becomes 17. It is not 0, it is not less than 5, so we'll add 17. Next, we will also add 5, right, because 5 is not 0, not less than 5, so we'll add 5. Next, I becomes 1, which is going to be small, and we skip over. Then I becomes 0, and what happens? We will stop here. We will stop here. So we have a means of actually triggering a stop with the special value called 0. Let's see. So when we added everything together, that's 22, right? So we might want to print a separator here. Yep, okay, so we get 22. Why is that so? Because it's 17 plus 5. All right, 17 plus 5. Because 0 is the special condition that stops the whole loop, and once we encounter 0, it will break out of the for loop. Remember, break and continue, they work for while and for loop, any loop. So that is the triggering point. If we cancel this, then we are implementing a special sum all the large revenues, ignoring small revenues. So we'll add 22 plus 11, so that's 33, and that's it. Anything 4 and below will not be added. You see that? Whereas the built-in function sum will not be able to do this filtering process. So by implementing our own loop, we can create very delicate or specialized or customized kind of control structure and logic to implement the things that we want.